can any of the quantum gravity models be tested?
So there are certainly quantum gravity models that can be tested, but I'm going to make a more general statement that is true of almost all quantum gravity models, is that the observations and what we know now, I'm trying to figure out how to say this properly. All of these quantum gravity models, the challenge in testing them is that the arena where these effects show up are in extreme conditions in the universe. In the down around the event horizon of a black hole, back at the beginning of the universe, because you need very high densities, because that's where the very high densities means that general relativity is going to be needed, but you also need very small scales, because that's where quantum effects show up. And so we can't produce the sort of energies in our particle accelerators where quantum gravity effects show up. It's difficult to observe environments in the universe where quantum gravity effects would show up. And so as of right now, there are a whole bunch of things that these quantum gravity models would say, but they all say the same things or they all say what we've already measured. And so as of right now, you could come up and say, well, I've got this quantum gravity model, and I'd say, okay, that's reasonable, but I don't have any way of testing that one is correct over this model over here. And I think that's going to take quite a while. You know, scientists are inventive people, and I'm sure they will come up with ways to do that. I have this suspicion that to really have a good handle on that, we're going to be decades away, just because of the energies in extreme environments where it takes to measure it. So as of right now, we cannot distinguish which quantum gravity model is correct. So we just have to wait and see.
So our location here is right by Fermilab.
Okay.
Where Leon Lederman worked, and I think the God particle was discovered. And they're currently they currently have a neutrino project where right now they're sending neutrinos through the Earth up to Minnesota, but they're actually moving it further up to South Dakota, which will take, I don't know, maybe a decade or so to get that in place. Do you expect that that the neutrino project or projects like that will help us get to answers on some of this?
My suspicion is what we're going to find measuring the neutrinos is that we're going to measure the neutrinos, and they're going to tell us what we already know. And what we already know is pretty impressive, I will say that. So there's this standard model of particle physics. And in the standard model, there are gluons that determine how the strong nuclear force operates. There are certain kinds of bosons, certain types of fermions. So you got electrons and tauons and muons. You've got various classes of particles, and one of those classes of particles are neutrinos. And neutrinos, for the longest time, were thought to be massless. We now know we've got pretty strong evidence that neutrinos have mass, just because of one of the weird properties that seems counterintuitive, but again, when you apply the physics, it works. Is that if neutrinos have mass, there's an electron neutrino, a muon neutrino, and a tauon neutrino. And if they have mass, those neutrinos can change from one flavor to the other. And we tend to think of things not changing, an electron is an electron all the time, but the idea that a neutron can change, or a neutrino can change from one to the other, was a little bit of a bizarre idea. What I think all of these neutrino experiments are going to tell us are they're going to allow us to nail down what's actually going on in the neutrino family. Hopefully, what's going on in the neutrino family will tell us something beyond that standard model. Now, I think the fact that neutrinos have mass at all tells us that something beyond the standard model must be there. But there's lots of different ways you can get that to happen beyond the standard model. So hopefully the neutrino experiments will narrow down and say, okay, these are the kinds of beyond the standard models that are going to work. And so I don't think they're going to weigh in on the quantum gravity realm, but anytime you build a new piece of equipment, it gives you data you didn't have before. And that's where a lot of our discoveries come from, is that we measure everything we can, and then we build this new thing, and it's like, oh, we didn't know this, and then we think, how do we make that work? And that's what often drives those advances. And so I'm not going to say no, it won't, but I suspect it'll just help us figure out that next step beyond the standard model of particle physics.